Hello everyone, my name is Washieu. I'm an incoming sophomore at the Browning School in New York City, and today I'll be discussing my second milestone in terms of my emotion recognition project with the Raspberry Pi. As you can see on your screen, I'm on Jupyter Notebook, an open source web application that allows users to perform live data analysis and run certain blocks of code individually. This notebook contains my work that pertains to training my model on being able to detect emotions upon being given an image. As with most supervised machine learning projects, a dataset is necessary. For this project, I utilized the FIR 2013 dataset, which is available on Kaggle.com. The FIR 2013 dataset contains over 34,000 images, all of which portray a certain emotion. Going back to our notebook, I've imported essential libraries that allow me to both perform data preprocessing and machine learning. For this project, I've used libraries like NumPy, Pandas, scikit-learn, and TensorFlow to complete the tasks that I've mentioned. Moving down our notebook, I read in the dataset and plotted examples of some of the images that are available on our dataset. However, as I was pre-processing the data, I realized that emotions will be quite difficult to accurately detect because each person displays their emotions differently, and the dataset only mainly contained neutral, happy, and sad images. Thus, I transformed the dataset into only containing neutral, happy, and sad images because those were the main images that the model would most likely predict. After transferring the dataset, I split the data to allow for most of the data to be trained on and some of the data to be tested on. Then, I construct my machine learning model to pass the images through and train the model for 100 iterations on my GPU, also known as a graphical processing unit. As you can see on the graphs, our model performed actually very well, with the accuracy increasing over each iteration and the loss value decreasing over each iteration. Then, I tested my model on the test dataset that I generated, was able to see that the model performed very well and accurately predicted most of the images. However, because of the Raspberry Pi CPU, which is much smaller than that of my regular computer CPU, I would need to decrease the size of my model. Thus, I performed model quantization, which would allow me to decrease the size of my model and allow it to perform much better under sustained load. Thank you for joining me on this milestone recap video, and I will update you all once I pass my third and final milestone.